Chapter 5, Motion, Laws of Motion. Okay. In last lecture we have discussed about what is dynamics of uniform circular motion, and first case that we have discussed is motion of vehicle on level circular road. Now in this lecture we will study about motion of vehicle on bank curve road, not on horizontal plane, but if plane is inclined at some angle. For example, like this. If it is horizontal, okay, and it is one inclined plane, also circular, and vehicle is moving on such bank curve road. Okay, then your question is what is motion of vehicle on bank curve road? Means we have to find equation, or we have to obtain equation of maximum safe speed. Clear about this? Okay. Now we know that in case of motion of vehicle on level circular road, required centripetal force for circular motion is provided by friction. In this case, which force will provide centripetal force for its circular motion? That we will identify. Okay, let this vehicle is moving on bank curve road having inclination theta with horizontal. Okay, and now yes, I am taking this vehicle as one point here, so that I can easily draw forces on it. Okay, so first of all, when vehicle is moving on bank curve road, bank circular road, we will identify number of forces acting on it. See, forces acting on vehicle. First force, which is always mg, that is weight, and it is always in vertically downward direction. Clear about this? So yes, if it is vehicle, mg is always acting in vertically downward direction. Second force, we know that second force is normal force, and it is always perpendicular to contact surface. So yes, here it is road, it is vehicle, so contact surface it is, and its normal force is like this. Clear about this? So second force is normal force, which is always perpendicular to contact surface. Third force is F, that is friction, and yes, this friction is parallel to contact surface. Now, whenever vehicle is moving on circular road, what is direction of impending motion? Yes, if you are taking turn, means you are moving on circular path, in which direction it is impending motion? Outside the road means in opposite direction of its center. See, this road is actually like this. Okay, so yes, its center is towards this point. Clear about this? So yes, impending motion of vehicle is outward. Whenever, see, if you are in giant wheel, okay, and yes, that giant wheel is rotating, then yes, we have one fear. Okay, yes, we will be thrown away. So yes, it is direction of impending motion. So yes, whenever you are moving on circular path, impending motion, if there is no friction, then yes, you will be slipped in this direction. So it is direction of impending motion. Clear about this? And yes, friction is in opposite direction of impending motion. So yes, friction is parallel to contact surface in this direction. Clear about these three forces? Okay, first force mg, always vertically downward. Normal force, which is perpendicular to contact surface. friction force which is always parallel to contact surface. So yes, we have three forces acting on vehicle: mg vertically downward, and normal to contact surface, F parallel to contact surface. Now in this case, as we have to find centripetal force that is acting towards the center, and yes, it is bent curve road, so its center, it is obviously in this side, obviously this side, yes or no? So yes, in this case we have to resolve each and every forces in horizontal and vertical plane. Here we have to resolve forces in vertical and horizontal plane, Clear about this? Yes, this case is different because in this case we have to find centripetal force. So yes, here we have to resolve forces in vertical and horizontal plane. So identify mg, it is already in vertical plane, yes or no? Yes, mg is already in vertical plane, but this F, is it in vertical plane? No, so we have to resolve this F. This N, is it in vertical plane? No, so we have to resolve N in two components. Clear about this? Again, we have to resolve forces in vertical and horizontal plane. Out of these three, mg is only in this vertical plane. See students, vertical plane means this vertical plane and it is horizontal plane. Okay, so yes, mg is in vertical plane, but F and N, they are not in vertical plane, so we have to resolve F and N. See, how to resolve F and N? F, it is in this direction. So how to resolve F? One in horizontal direction and one in vertical direction. Clear about this? Clear about this? One in horizontal direction and one in vertical direction, in vertical plane. Okay, now to find component, we know that we need angle. See here, one Z is found. See here, Z is found. So if this angle is theta, obviously this angle will become theta. Simple. So F is making angle theta with this component. F is making angle theta with this component. So obviously it becomes F cos theta. Clear about this? And this another component becomes F sin theta. Clear? Okay. Again, F is parallel to contact surface in this direction. If this angle is theta, this angle is also theta. F is making angle theta with this component. So it is F cos theta, and another component is F sin theta. Okay, now I will resolve normal force in two components. See, it is normal force, so it's two component. Here it is in vertical plane and here it is in horizontal plane. Again, to find components we need angle. We know that friction force and normal force, they are perpendicular to each other. So if this angle is theta, this angle will become 90 minus theta. And for that, it is horizontal plane, it is vertical plane. So again, angle between them is 90. So this angle will become theta. Clear about this? Clear about this? So yes, again, this angle is theta. N and F, they both are perpendicular to each other. So if this angle is theta, it will become 90 minus theta. Between horizontal and vertical, we know that angle is 90. If it is 90 minus theta, then obviously it becomes theta. Okay, now we do not require this 90 minus theta. Now see, here it is. N is resolving two components, one in vertical plane, one in horizontal plane. N makes angle theta with this component. N makes angle theta with this component. So yes, it is N cos theta. So yes, it is N cos theta. And it is N sin theta. And it is N sin theta. Clear about this? So now we had three forces, mg, n and f. Out of the three forces, we have resolved f and n. Clear about this? Okay. So yes, see how to write. Okay. See, as shown in figure, we have resolved f and n. Clear about this? Clear about this? Now see here, as vehicle is not performing any motion in vertical plane, Yes, whenever you are moving on road, vehicle is moving in horizontal plane. Yes or no? On road, it is not moving up or down on road. Yes or no? So yes, we can say vehicle has no motion, has no acceleration. Motion means acceleration in vertical plane. In vertical plane. Okay, as vehicle has no acceleration in vertical plane, means sigma f is equal to 0 in vertical plane. In vertical plane. Clear about this? Now vertical plane means what? Now vertical plane means what? See, it is vertical plane. See, identify numbers of forces acting in vertical plane. N cos theta, mg and f sin theta. From figure you can easily say n cos theta is acting in upward direction while mg and f sin theta are acting in downward direction. So yes, remember, whenever sigma f is equal to 0, force is equal to 0. It means forces acting in upward direction is equal to in downward direction, because here we have to take vertical plane. So for vertical plane, if sigma f is equal to 0, what is condition? Forces acting in upward direction is equal to forces acting in downward direction. Clear about this? So yes, how to write? Forces acting in upward direction, n cos theta, is equal to forces acting in downward direction, that is f sin theta plus mg. F sin theta plus mg. Clear about this? Okay. Now I will make mg as subject. Then mg is equal to, it is n cos theta. It is n cos theta minus f sin theta. Minus f sin theta. Clear about this? Clear about this? So yes, let it is equation number 1. Let it is equation number 1. Now, see, this f sin theta, mg and n cos theta, yes, they balance each other. N and f we do not have to consider because we have resolved them. So remaining two forces are n sin theta and f cos theta. See, this n sin theta and f cos theta, they are acting in horizontal direction, in this direction, towards center. Towards center. Towards center. Yes, this n sin theta and f cos theta, they are acting towards center. It means these two forces are providing centripetal force for uniform circular motion. Yes, so here how to write? Okay, here n sin theta and f cos theta provides centripetal force. Provides centripetal force for circular motion. For circular motion. Clear about this? Then how to write? If radius of circular path is r. If radius of circular path is r. If radius of circular path is r and speed is v, then required centripetal force, that is mv square upon r, is provided by these two forces, that is n sin theta plus f cos theta. Clear about this? N sin theta plus f cos theta. Any doubt? Any doubt? Okay, so yes, here again we have three forces mg, f and n. We have to resolve forces in vertical and horizontal plane. mg is already in vertical plane, do not resolve. F resolved in two components, n resolved in two components. From figure we can say vehicle is not moving in this vertical plane, so n cos theta is equal to mg plus f sin theta. These two forces are acting in horizontal direction towards center. So yes, these two forces will provide centripetal force. Clear about this? It is equation number 2. It is equation number 2. Now I am taking ratio of equation 2 divided by 1. Equation number 2 divided by equation number 1. See, m v square upon r divided by mg is equal to. Here it is n sin theta plus f cos theta divided by in denominator here it is n cos theta minus it is f sin theta minus it is f sin theta. Clear about this? Now yes, if in last lecture we have also discussed if friction force is more then speed is also more. So here if I am taking this friction as Fs maximum then I can write this V as V maximum. Okay, if F is equal to Fs maximum then V is equal to here is V maximum. Clear about this? And we also know that Fs maximum is equal to it is mu s into n. Yes or no? Fs maximum is equal to it is mu s into n. Yes or no? Yes it is. Then see how to write in this equation. M cut. Clear about this? M cut. Then here it is V square upon Rg. Here it is V square upon Rg. Clear about this step? Okay, see again here how to write. Understand? We have to take ratio of equation number 2 divided by equation number 1. Equation number 2 divided by equation number 1. Okay, so yes, it is mv square upon r divided by mg is equal to n cos sin theta plus f cos theta divided by n cos theta minus f sin theta. If I am taking friction force Fs maximum is equal to mu s into n, I will get maximum speed. So yes, in this equation m cut V I have to replace by V maximum is equal to this side here it is n sin theta plus mu s into n cos theta divided by n cos theta minus mu s into n sin theta minus mu s into n sin theta. Clear about this? Again, f I have to replace by Fs maximum, and Fs maximum is equal to mu s into n. Fs maximum is equal to mu s into n. Now see, right hand side, n common. In denominator, n common. So yes, n is cancelled out. So how to write this equation? V square maximum upon Rg is equal to it is sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. Clear about this? Now right hand side I will divide numerator and denominator by cos theta. How? See here it is V square maximum upon Rg is equal to V square maximum upon Rg is equal to here it is sin theta plus mu s cos theta divided by cos theta divided by numerator is divided by cos theta. Similarly, cos theta minus mu s sin theta divided by cos theta. Clear about this step? Divide numerator and denominator by cos theta. Now how to write? See, V square maximum upon Rg is equal to V square maximum upon Rg is equal to see carefully here. See carefully here. Sin theta upon cos theta. Sin theta upon cos theta plus mu s cos theta upon cos theta. Okay. Divided by, how to write this term? You have to separate this cos theta. You can write this cos theta in denominator of each term. Divided by cos theta upon cos theta minus mu s sin theta upon cos theta. Okay, again see, sin theta upon cos theta plus mu s cos theta upon cos theta. In denominator, cos theta upon cos theta minus mu s sin theta upon cos theta. Clear about this step? Then yes, here it is V square maximum upon Rg is equal to sin theta upon cos theta. Yes, it is tan theta. Plus cos theta upon cos theta cancel out. So yes, here it becomes only mu s. Divided by cos theta upon cos theta means 1 minus mu s sin theta upon cos theta means it is mu s tan theta. It is mu s tan theta. Clear about this? Now make V square maximum as subject. Then yes, V square maximum is equal to Rg, and here is mu s plus tan theta upon 1 minus mu s tan theta upon 1 minus mu s tan theta. Okay, and now if you want to find V maximum, then yes, you have to take square root on both sides. You have to take square root on both sides. Clear about this? Okay, yes, these mathematical steps, if you write 2 or 3 times, you will easily understand. Yes, this theory is easy. Yes, this theory is easy. Clear about this? Again, draw proper figure. N cos theta is equal to mg plus f sin theta. Then these two forces will provide centripetal force. Equation number 2 divided by equation number 1, and this mathematical calculation. Yes, last equation we have to write that V maximum is equal to under root Rg under root mu s plus tan theta upon 1 minus mu s tan theta. See how to write it. Okay, see, yes, what is last step? V square maximum upon Rg. V square maximum is equal to Rg mu s plus tan theta upon 1 minus mu s tan theta. Now if I want to make V maximum as subject, then V maximum is equal to under root Rg mu s plus tan theta upon 1 minus mu s tan theta. 1 minus mu s tan theta. Clear about this? Then yes, it is equation of maximum safe speed on bank curve road. Clear about this? Yes, you have to remember this equation. What is each and every value? R, radius of circular path. G, that is gravitational acceleration. If you are not given, then yes, you can take value of 9.8. Okay, and yes, sometimes to make calculation easy, you will take G is equal to 10 meter per second square. Mu s is coefficient of friction between road and wheel, road and tire. Okay, theta is this angle. Okay, at which it is inclined. Clear about this? Last one special case. If mu s is equal to 0, means no friction. So in this case, what is speed? In this case, V is equal to, here it is, under Rg 0 plus tan theta upon 1 minus mu s into 0. Clear about this? Then mu s into 0, it will become 0. 1 minus 0, it is 1. So here V is equal to, it is under root Rg tan theta, and it is called optimum speed. Optimum speed means in this active speed there is no friction, or we can say value of friction is very small. So yes, there is no wear and tear of wheels. Means with this speed, life of wheel can be increased. Clear about this? So yes, for this theory, you have to remember 2 equations. First equation of maximum safe speed on bent curve road. Second equation is about optimum speed. That is VO is equal to under Rg tan theta. Again, R is radius of circular path, G is gravitational acceleration, and theta at which the road is bent. Yes, students, it is one important theory from chapter number 5. Motion of vehicle on bent curve road. Yes, we have 2 cases. Motion of vehicle on level circular road, level curve road, and motion of vehicle on bent curve road. So first of all, understand question, which theory you are asked. And yes, Again, it is important theory. Take care about this figure and also this mathematical steps. See, here we have each and every step clearly. Clear about this? Okay. So yes, watch videos, make notes, solve your doubts, and yes, do like, share and comment our video.